how you're going to identify combustion is look at that oxygen, water, and carbon dioxide. Every single combustion reaction is something, this hydrocarbon, reacting with oxygen to make water and carbon dioxide. These three things will always be the same. And you can see them down here. O2, O2, O2. You can see here, H2O, making H2O, making H2O. CO2, each one of these makes CO2, CO2. You're going to see those three things in every single combustion reaction. The only difference is going to be what is your fuel for this combustion reaction. Combustion reactions, whether you light a candle, burn a fire, burn sugar, burn methane, or Bunsen burners and back, all of those are just different sources of fuel. All of those are hydrocarbons. So what we call this with compound, that compound is a hydrocarbon. We mentioned that yesterday. And we call it a hydrocarbon because each of these contains hydrogen and carbon. So here, whatever it is, it's going to be a hydrocarbon reacting with oxygen to make water and carbon dioxide. That's how you identify combustion. There's no good ABCD pattern. What you want to be on the lookout is for these four things. That's the key to combustion reactions. Pause for questions. Any pyromaniacs out there? Oh, just bashful pyromaniacs. I know we got a few. Single replacement and then double replacement. That's what we're going to cover next.
Someone's knocking at the door.
Hello. Yep. Thank you so much. Before I forget, like how they describe this, because single means one, and replacement means it's taking the place of another thing. So you have one thing replacing another in a compound. So A, in this instance, is going to bump out B, so now you have a new compound, AC, and now something new too, B's alone. Each of these you got to create something new. Down here, eventually, once we're more confident, you guys are going to be predicting products. What that means is you guys are going to look at this and then you're going to be able to tell me what is being made. I'm going to give you a little preview. Today, don't worry, you're not expected to predict products today. Today it's just identifying which is which, but I want to show you where we're taking this. So for this one, I would say, okay, this is like my, so this would be like my A, the one thing that's alone. And it doesn't matter which order it is as long as it's on the reactant side. So we have A, and that's mixing with BC. Here's my BC, my compound. So let's see, I want to be consistent. Here's my B, here's my C. So I know A is going to have to bump out my hydrogen. And I know magnesium is bumping out hydrogen and not chlorine because it's always a positive and a negative. Magnesium's positive 2 charge, so I know it'll have to replace the positive 1. So cation replaces cation because they're both positive. Yep, I went there. It happened. So I know it'll be magnesium taking the place of hydrogen, so it'll be magnesium and chlorine. Oh, I'm going to use black. Magnesium and chlorine. This is why you don't want to forget about last unit. Because when you're predicting products, check charges. Magnesium's charge. If you look up here, magnesium's charge is +2. Take a peek or take a peek on your table. +2. Chlorine's charge, -1. It needs to be neutral. So if magnesium is giving up 2 electrons, how many chlorines do we need? 2. Nice. So I know that's the magnesium chloride that would be created. And then the B alone, that would be my hydrogen. And I would put H. Now be careful. We haven't talked about we haven't talked about diatomics yet. Here's your first little sneak peek and preview. It's not just H alone, it would have to be H2. And the reason for this is hydrogen has one valence electron. How many valence electrons can fit in the full first shell?
2.
2. It wants to. It's not happy. So what it's going to do is, if we have a bunch of hydrogen around each other, it's going to go find another hydrogen and be like, hey dude, want to share? And that other hydrogen is be like, oh my gosh, yes, this is brilliant. So they're going to share these electrons and form a covalent bond so that it's H2. Now they're both happy. This hydrogen feels like it has 2 electrons. This one feels like it has 2. They make each other happy. They're sharing. So a quick way to figure out which ones are diatomic, look on your periodic tables or take a look up here. Diatomic, double bubble. You see those 2 little circles right next to each other? Any compound that is a diatomic, meaning it cannot just hang out alone by itself, has a double bubble. And you'll find it with hydrogen, double bubble, and then also over here. Nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. All double bubbles. You don't have to memorize it, but you want to know it's there, and this is why, and I'm going to come back later and talk about it more. But just heads up, that's why I have to say H2. All we're doing right now, though, is identifying this pattern as single replacement. Because you have one thing replacing another in a compound. So when that makes this compound over here, we have A paired up with C, AC, and then also we have hydrogen, B's alone. So that's that pattern. One thing replacing another. So in this second one, I'd say zinc is going to replace hydrogen, because cation replaces cation. So it'll be zinc and this SO4, charges check out, +2, -2. And then the other one alone would be hydrogen alone.